Hello, I'm saying greetings again to everyone here. Pardon me. Alright, I want to look at decimal figures and decimal places. We have heard that numbers walk on three legs. It's either you have a whole number, you have a decimal number, or you have a fractional number. Yes, so for some of us who are in high school, middle school, we were just in primary school, we have been exposed to these different legs that numbers work on. But I want us to look at decimal numbers. See this. A decimal figure, which is also the same thing as saying a decimal number, is a number that includes a decimal point. Take for instance 0.32. This is a decimal because of this decimal notation here. So this is a decimal number. If I take out this decimal notation, I'll just have this. It should be 32, and there will be two significant figures here. What are we talking about? We're looking at decimals, and we have said that decimal numbers are numbers that includes a decimal point, and it shows parts of a number less than 1. So it shows you all the parts of the number that is actually less than 1, or that 1 is greater than. But before we do anything, I want to show us all the numbers between 0 and 1, so that when we say 0, 1, 2, 3, 4, 5, between 1 and 2, there are so many numbers between 0 and 1. There are lots of numbers too between, all smaller than 1. And what are the numbers between 0 and 1? 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9. And after 0.9, we have one whole. Let me also say something quickly, in case we want to consider the size of these numbers. If you even look at the board carefully, you will notice that from 0.4, the numbers here are smaller than this. I did it intentionally so that we will know that as the numbers move like this, from left to right, to approach your 1, the size of the numbers increase. Having said that, it means that 0.6 is greater than 0.4. So the point is, the closer a number is here to one whole, the bigger the decimal number. And the farther away it is from one whole, the smaller the number. So numbers closer to 0 are smaller compared to numbers far away from 0. That is the numbers heading towards one whole. So first, I want us to look at these numbers. These numbers are called decimal numbers. So when we see a decimal number, we know that first of all, you need to be on the lookout for the decimal notation. The decimal notation is also what we call the decimal point. I want to do something. Let me use these numbers here as an example. So let's say we have 0.2. Let's work with 0.2. Because of the presence of this decimal point, 2 here is a number that is less than 1. So one whole will be greater than 0.2. Why? This decimal notation. That means 2 as a number is between 0 and 1. So all the numbers between 0 and 1, they are all less than 1. That means they are all smaller than 1. Or 1 is greater than all the numbers here. Alright, so this is one fact that we need to take note of. After the decimal point here, there is a position here. And what do we call this? The first position, or the first place immediately after the decimal point, is called the tenth. So this 2 here belongs to the 10th. Please. 10th. 2. 10th. And if I say this is the 10th, it means the place value of 2 here, the place value is 10th. How will I write it in form of a decimal fraction? Because of the 10th position, and I have 2 here, this will be the same thing as saying 2 over 10. What do I mean? To my 5th graders, 4th graders, 6th graders, please take note of this. Even when you get to middle school, note that here, after the decimal point or the decimal notation, the first place or the first house or the first position, the name of any number that will fall under this will be called the 10th. So that this is 2/10. I like that we note that there is a difference between the tens, like TENS, tens, and tenth. They're not the same. They're not the same. This one, for the purpose of this corresponds to this. And immediately after the decimal point, I can only see one position, or I can only see one number. So if you're asked, how many decimal places are here in this decimal number? Because immediately after the decimal point is only one position or one place or just a house, we're going to say that here we have one decimal place. So in 0.2, there are one decimal. We have just one decimal place. There is a decimal place, please. All right, so I picked this number from here. But apart from 0.2, there are other decimals. I'll give you another example. So we can also let's look at 0.0035. Please, I'm going to take this off so that I don't go too far. Let me stay at the point. If you want to get a paper and a pen, or a notebook and a pen, just get it so that you will take note of the points as they come. So this is, okay, let's make this bolder. Let me just increase like the font size. So this is 0.0035. Notice this. I'm going to place my decimal notation how it should be. This is a decimal number. Why? Notice this. There's a decimal point here. And from what we should know by now, for those of us who are following, you will notice here that the first non-zero is 3. So there are 2 non-zeros here. That will mean that there are 2 significant figures here. So in case you're asked, how many significant figures are here? First, let's leave decimal places. I'm coming to that. How many significant figures are here? Know this, that your significant figure begins with the first non-zero. And because it begins with the first non-zero, this is the first non-zero. So that this is 3 and this is 5. There are 2 significant figures. So while we have 2 significant figures, let's count the number of decimal places. Decimal places. The first decimal place begins with the first position after the decimal point. So that this is the 10th, second position, 100th, third position, 1000th. Oh, this is Gallus Domesticus. And this is the 10,000th. There is a creature, binomial nomenclature, Gallus Domesticus. Okay, Gallus Domesticus, binomial nomenclature. That's what's making that hell of noise there. All right, so look at this. That's showing the biological clock. I don't know why it's crowing right now. So this is the place value arrangement for numbers like this. So I can see the first place 1, 2, 3, 4. So that means For 0.0035, there are 4 decimal places. Note this, for a decimal place, you start to count after the decimal point. The number of digits or positions you have after the decimal point tells you the number of decimal places that you have. So that these 3 here belonging to the thousandth, I'm going to write it as 3/1000 decimal fraction. And this 5 belonging to the 10,000th, I'll say this is 5/10,000. So it is very important, very, very important that we take note of this. This is trying to expose us to the skeleton of decimal numbers, so that when we understand this, when we're given different sets of decimal numbers, we can easily arrange in increasing order of magnitude from the biggest to the smallest, or from the smallest to the what? From the smallest to the largest. That is in ascending or descending order. We take advantage of the place value to arrange this. So what is my point? My point is that a decimal figure or a decimal number is a number that includes a decimal point. 1. It also shows parts less than 1 whole. And I also seized the opportunity to expose us to all the numbers from 0 to 1. I'm talking to my 3rd graders, I'm talking to my 4th graders. It is important that you take note of this. So for my 5th, 6th, 7th graders, if you're giving numbers like this, if you're giving this, take for instance 0.0351, say you are giving this. While there are 3 significant figures here, 3SF, there are 4 decimal places. So like I said, the number of decimal places does not always translate to the total number of significant figures, and the number of significant figures does not always translate to the number of decimal places. So you need to be on the lookout for this. You should be able to identify the number of significant figures present in a decimal number, a whole number, or a mixed number, and the number of decimal places present in either a mixed number or a decimal number. If we understand this, then it will be easy for us to approximate round numbers correct to 2, 3 decimal places, 1, 2, 3 significant figures. First, we need to understand the skeleton that I've exposed us to. So until I meet you again, just keep learning, keep solving.